You are about to watch the best thing we have ever created, showcasing using Ekahau latest technologies to optimize existing Wi-Fi and design a new 6 GHz Wi-Fi for 1 million square feet L'Oreal warehouse.
We are at the largest warehouse I have ever seen in my life. Over 1 million square foot of warehouse.
10 football fields large. Can you imagine?
I couldn't imagine, but now I'm here, I still can't even imagine how big this is.
Now, just to give you a quick overview, we've done 120 kilometers walking around this warehouse, and the introduction is actually the last piece of content we are recording here.
Yeah, so it's actually a bit like playing real life human Pac-Man with the amount we have to avoid getting hit by forklift trucks as we're walking around. And we're here because we're helping L'Oreal with their existing Wi-Fi network that they've got here, see if there's any ways we can improve it, optimize it, make it slightly better for them, whilst also capturing all of the data that we need to design a brand new, shiny, state-of-the-art 6 GHz Wi-Fi network for a warehouse.
So stay tuned for that content, because we are using two different types of access points and antennas and positioning them against the ceiling, against the walls, suspending them down. It is really interesting to talk about and think about how to do a perfect design for fast roaming, high capacity, future-proof, to get AR and VR running here, and most importantly for everyone to be happy, not dropping off, and amazed with how great the Wi-Fi can be.
But the first step before we start on our marathon of site surveys is to get the full picture of the requirements for what a successful network looks like in an environment like this. We're up here on the mezzanine overlooking what is actually 1 million square feet of L'Oreal product. Finally, somewhere that can actually store all of my hair products. There are a few things that stick out right away as challenges to me. These ceilings are incredibly high, around 13 meters or about 45 foot. And you can see that the existing design has APs mounted way up by the ceiling and using omnidirectional antennas. We're going to want to bring them down much closer to the action and use a different type of antenna, because one of the biggest challenges with warehouse Wi-Fi is providing good roaming and coverage for client devices whilst also minimizing contention, or CCI. We're also looking at metal everything everywhere, which is just going to potentially cause a lot of interference and reflections of the Wi-Fi signals. On the positive side, we're working with air-conditioned space. The products housed here aren't meant to be stored at crazy freezing or hot temperatures, so we're not going to need to incorporate any external housings for our access points. We've also identified a few different requirement areas. We've got massive aisles of storage, but we've also got this second floor mezzanine area that facilitates things like processing returns. And just off to the side there, we've also got a packaging area where the product is pulled from the shelves and prepared for shipping. 3 very different areas that will require different considerations for the design. As for the client devices, we've got a mix of forklifts and foot traffic with inventory scanners, as well as some other wireless scanners in the packaging area that are all going to be highly reliant on the Wi-Fi. This is the sort of textbook business critical Wi-Fi scenario. The client devices down there are scanning inventory, assembling orders, shipping products. Outages and issues will directly impact the bottom line.
We are really fortunate to be able to see the devices and processors in action. When we met with the networking team, they talked us through how the systems interact with one another, almost like you would get a tracking notification when you buy something online, and then you watch as the package goes from the warehouse to a regional hub, then to a more local distribution center, and then finally by carrier to your home. The different scanners are creating exactly the similar journey from place to place, documenting where everything is, providing order that streamlines these processes. Time is money, and Wi-Fi is absolutely critical in every possible way. One issue the current network suffers from is very bad roaming. When these forklifts and these scanners can't effortlessly roam from AP to AP, they lose connectivity and have to stop where they are and attempt to reconnect to the network before they can proceed. These short disconnections, they add up big time, and they also cause a lot of headaches for you, for the IT team, who has to get involved with troubleshooting all this bad stuff. With our new network, proper roaming is a must. And in the future, more automation, more modern applications like AR will be relying on Wi-Fi even more. So it's absolutely crucial to prepare for that today. We've also learned that seasonality plays a huge role in this warehouse. In speaking with L'Oreal, it's not uncommon for products to shift and phase out or get moved around. Quarter to quarter, the products on these shelves, on racks, could be completely different, and many of them are liquids based, which means they are super massively attenuating or absorbing Wi-Fi like crazy.
At this point, we have a really solid understanding of the business requirements for Wi-Fi. So let me introduce you to the massive 1 million square foot floor plan we're working from, and the different requirement areas and Wi-Fi requirements we'll be designing for. To give a bit of context, this warehouse is the same size as 10 football fields combined. We have 3 distinct requirement areas: the storage rack space, packing space, and mezzanine. We also have a few exclusion areas that the on-site team helped identify as out of scope. The ultimate goal for the requirements of the Wi-Fi network for the warehouse is to provide a fully future-proofed 6 GHz network that will allow all their business critical devices to be able to seamlessly work and roam throughout the warehouse. They also wanted to have redundancy from an RF perspective. So if they were to lose an access point for some reason, like a cable getting cut by mistake or a faulty AP, there would be enough redundancy coverage from a nearby AP to cover that temporary failure. Let me talk you through the coverage profile that we set as the requirements for the project in Ekahau AI Pro. So what we're looking at here right now is the L'Oreal coverage requirements for the warehouse. And what you can see here is that we actually got the 2.4 GHz band all currently set to off, because there are no devices that L'Oreal need to support in this environment that work in the 2.4 GHz frequency band. So first of all, taking a look at our primary signal strength, we've been setting this to -67 dBm on both 5 and 6 GHz to ensure that all of the client devices are going to have a great primary signal strength no matter where they are in the warehouse. The second requirement we've got here is for the secondary signal strength, and again set at -67 dBm on both 5 and 6 GHz. And the reason why we have this in the warehouse, some people might think that this is a little bit aggressive in a typical warehouse. Well, we've gone for this because we also want to provide that redundancy for the environment. So if they was to lose an access point in any kind of location, there'll be that backup secondary coverage requirement, which is going to help with the redundancy, but also for roaming of the client devices. We haven't got any requirement for tertiary signal set as for right now, and our signal to noise ratio minimum that we're trying to achieve here is 25 dBs. The minimum data rate that is going to be set for the environment is going to be 24 megabits per second, and we're allowing for up to 2 devices on the same channel for the channel interference. As this is a warehouse and there's going to be quite a highly reflective environment, it's going to be pretty normal to have a few access points sharing the same channel. So that's why we have gone for that there. And then the rest of the requirements really are more for the kind of like active testing. So we've got that kind of set to off for now. Due to the physical makeup of the warehouse, with many different types of areas such as high racking aisles, big open space areas, and the mezzanine with no physical walls to attenuate the Wi-Fi, we need to get quite creative with how we're going to provide a Wi-Fi network that would meet these requirements, and we plan to do this by using multiple different types of access points and antennas, and sometimes not in the most conventional way. I wonder if anyone began to realise my makeup pun, or if I need to make it a little bit more obvious. For the high 13 meter storage rack aisle areas, our plan is to use an AP that has directional antennas and to mount 2 access points at either end of the aisles with a certain amount of degree of tilt.
That's delightful, mate, but let's cut back to us in the warehouse as it's so much more cool. Or should I say cooler? Actually, it wasn't that cool, it was 18 degrees.
Super exciting stuff. We're in a warehouse, and this rack in this warehouse is actually over 100 meters in length. And for the very first time, we are testing out 6 gigahertz using inbuilt directional antennas in the 9166D1 access point. So we're here in Germany, in L'Oreal, at this warehouse. And what are we doing, Matt?
Yeah, so we are doing a beautiful new redesign of a Wi-Fi network to make sure that we are future-proofed. And as you can see, we are bursting from excitement because this might be one of the first 6 gigahertz enabled warehouses in the world. So we've mounted the access point at 5 meters height to match the other mounting locations, possible mounting locations. On the other side of the warehouse, we have to mount it at 5 meters height. So we want to have them all mounted on the same height. How about angle of tilt?
So before we even came to the warehouse, we actually did a predictive design simulation in Ekahau AI Pro. And what we did is we mounted the access point with a minus 30 degree angle of tilt, because what we thought that would do is it would give great coverage directly below the access point, but also as you walk down the aisle and you get towards the other end of the aisle, you have great connectivity as you're moving down the aisle. And as you start to get towards the end of the aisle, this device, the client device they're going to be using here, it should then roam to the AP at the other end of the aisle.
Yeah, we actually measured that, right? So we've done the 6 gigahertz AP on a stick survey. So look at Matthew's screen, and you can see that towards the end of the aisle, we are dropping to around next 67 from the Sidekick perspective. That will translate to around next 75, next 77 from the barcode scanner's perspective. And that means that it will roam inside the aisle. And when you go around the aisle, you won't drop off. You're ready for very fast roaming. You can even run around the warehouse and you won't drop off. So you are ready for the AR and VR in this beautiful environment.
Exactly, so we measured it with our Sidekick 2 using the survey app, and that's how we can see this lovely heat map coming from this access point. And then the last thing that we're going to do, we've got one of the barcode scanners here for what they're going to be using in the warehouse, and we're going to test it connecting to the access point as we move down the aisle, compare it to the Sidekick so we can get that offset measurement. So what do we call it? The
LCMI?
Yes.
Least capable, most important device. That is apparently me, right?
Otherwise known as Mac. So one of the really key important things that we need to do when we do our site survey on site with the client devices is understand how they're going to see the Wi-Fi compared to your measurement device, which we're using the Sidekick 2. So this is what's called creating an offset. So Mac, how far are we away from this access point right now?
So currently we are 5 meters away, and we will be testing the RSSI, measuring the RSSI as Sidekick sees it, high sensitivity, high quality device, and a low quality or kind of low quality barcode scanner that is just a small phone. So what's the difference?
So yeah, Tim, if you want to come a little bit closer and show the screens right now, what you can see on my analyzer application, we can see that the Sidekick is currently seeing the signal strength from that access point on 5 gigahertz at around minus 37 dBm. However, if you take a look at the signal strength of the client device down here, it's at around minus 44 dBm, and it jumps around a little bit. So at the moment it's showing anywhere between a 7 to 10 dB difference between the 5 gigahertz radio of the client device versus the Sidekick 2. So we just let it hover around for a few moments and see what the signal strength is, and then what we can do is we can calculate the difference, the offset between our client device versus our Sidekick 2, and apply that to our visualizations in Ekahau. So when we are doing our design, our validation, we can ensure that the Wi-Fi network is going to be spotless with the client devices as well.
Okay, and let's move farther away from the access point.
Okay. So what was the reason why we were 5 meters away initially, Mac?
I don't know, what?
Because if you're too close to the AP, because of free space path loss, then you could see big fluctuations in signal strength from the readings of your client devices. So when you're doing this type of testing, you want to be at least 5